Lesson 5.5, Performing Function Operations. Our essential question: how do you add, subtract, multiply, and divide functions? Today we're going to be looking at subtraction. And I see if I'm going to form an f minus g rule of x, I'm supposed to take all of f and then subtract all of g. So let's go ahead and do our first example. I am being asked to do f minus g of x, which says I'm supposed to take the entire f and subtract the entire g. So I see that my f is blue, so I need my blue f, which is a 5x, and I'm supposed to subtract the entire g rule. And that entire g rule is an entirety of x plus 2. Now, if you forget to put this entire grouping symbol around the g, you're going to forget to distribute the negative, or the minus sign, to all of g, which means you're not actually subtracting all of g. That's why g is an entire grouping symbol, because you have to subtract everybody in here. So what do I actually have? I have a 5x. I now am supposed to subtract this x, and I'm now supposed to subtract this positive 2. So now subtracting a 2. So combining like terms, 5x minus x is a 4x, and there is no other constant for the minus 2, so that's minus 2. So this is my final answer. The number one most common mistake when you're doing subtraction is to subtract everybody in the next function. So let's try our first practice problem. Standard 5.5, number 2, we are subtracting two functions. So I'm going to split my paper. Over here, I'm going to solve the f minus g rule, and then I'm going to evaluate. On this side, we're going to look at the domains. So I'm asked to do the f minus g function of x, which means I need to take all of f of x and subtract all of g of x. So my f of x is right here. So my f of x is 3x to the third minus a 2x squared plus 5. This is all of f. And now I'm supposed to subtract all of g. So here is all of g, and that's going to go right here. All of g is. So that was an x to the third minus a 3x squared plus 4x minus 2. Again, the most common mistake. You're forgetting to subtract all of g. So what do I have? I already had a 3x to the third. I already had a minus 2x squared. I already had a plus 5. I'm now subtracting an x to the third. I am now subtracting a negative 3x squared, which means I am now actually adding a 3x squared. I'm now subtracting a 4x, and I'm now subtracting a negative 2, which means I'm actually adding. So combining like terms, x to the thirds can only go with other x to the third, so 3 minus 1 is 2, so 2x to the third. X squareds only go with other x squareds. Negative 2 plus 3 gives me 1, so there's 1x squared. X's can only go with x's, that's minus a 4x. Constants can only go with constants, 2 and 5 is 7. So this is my f minus g of x rule. Now we're being asked to evaluate this new function at negative 2. So I have my entire f minus g of x equaling 2x to the third plus x squared minus 4x plus 7. We're asked to evaluate it at negative 2. So my f minus g at negative 2, every single one of these x's needed to get replaced with negative 2's. It's important that you put the negative 2 in parentheses because with the exponents, it changes everything if you forget it. So first thing I need to do is my exponents. So I have 2 times the entire quantity of negative 2 to the third power gives me a negative 8, plus the entire quantity of negative 2 to the second power is a positive 4. Now I go through and I'm going to multiply. So I have a negative 16 plus 4. This is plus 8, and that's plus 7. So adding and subtracting from left to right, I get a positive 35. So my f minus g at negative 2 is a positive 35. So now looking at our domains, we know we need to find the domain of each individual, and then we'll find the domain of the new function. So let's go ahead and look at the domain of f of x. This is a cubic. We know that all cubics are going to look something like this, where they're always to the left and always to the right. So that means f of x, since he is a cubic, his domain is going to be all real numbers. looking at the domain of g of x. G of x is also a cubic because its highest degree is 3, which means it will also look like this, which means it will always go to the left and always go to the right, which means my domain for g of x is also going to be all real numbers. When I am looking for the domain of my new function f minus g of x, I'm asking myself, what did f and g have in common? Because that's what this domain will be. So if f says I can use everybody, and g says I can use everybody, then they have everybody in common. So my domain for the new f minus g of x rule is also all real numbers. So let's do our next problem. I have my f of x rule, and I have my g of x rule. I am being asked to find f minus g. So here's me splitting the paper. Over here is where we're going to talk about the domains. And I'm doing f minus g of x, which means I'm supposed to take my f and then subtract all of my g. My f rule is this blue, so this was my f rule. And I'm supposed to subtract all of my green g. So this is my green g rule. So there's all of my f rule. And then I needed to subtract all of the green rule, so here's me subtracting all of my green rule. So what do I actually have? I already had the blue, so I already had the 1/2 times the third root of x. Now I'm subtracting this entire green, 9/2 times the third root of x. So I see that I had a negative half of these third root x's, and I'm being asked to subtract 9/2 of these third root x's. So I'm being asked to count the third roots of x. Negative 1/2 minus a 9/2 gives me a negative 10/2, which simplifies down to negative 5. So I have negative 5 times the third root of x. This is my new f minus g of x rule. But now we're being asked to actually evaluate when x was a negative 1,000. So I have the f minus g at x equaling negative 5 times the third root of x. We're no longer using x. We're going to use the negative 1,000 instead and evaluate. So I have f minus g at negative 1,000 equaling negative 5 times the third root of negative 1,000. All of my x's were replaced with the negative 1,000 I was told. So let's evaluate. So I have negative 5 times the third root of negative 1,000 is a negative 10. Negative 5 times negative 10 is a positive 50. So my f minus g at negative 1,000 is a positive 50. Now let's go ahead and look at our domains. We need to find the domain of f of x. Looking at our problem, it's a third root. You will recall that the third root parent looks something like this. Because we're not adding and subtracting on the inside, then we're not moving this guy left and right. Because we're not adding and subtracting on the outside, we're not moving him up and down, which means that this negative 1/2 just tells this guy to have a vertical shrink. So we're not really moving, we're just vertically shrinking. So that means my domain still goes forever in the left and forever in the right, which means my domain is still all real numbers. Let's look at our domain for g of x. G of x is also a cubic that has no adding and subtracting on the inside or adding and subtracting on the outside. So he is not moving left or right or up or down. So this function also has a vertical stretch, which means he just gets stretched more. So he is still forever to the left and forever to the right, which means my g of x also has all real numbers for its domain. So now we just need to analyze the domain of our f minus g rule. If f says I could use everybody, and g says I can use everybody, that means the new rule of f minus g also says I can use everybody. So my domain is also all real numbers. Let's go ahead and look at the next problem. So I'm going to split my paper down. I'm going to do my domains over here. We're asked to do the f minus g of x rule, which means I'm supposed to take my f of x and subtract my g of x. My f of x is this entire rule right here. So I'm going to put my entire blue rule right here. And I'm told I need to subtract. and we're subtracting the entire g of x. So here is going to be my entire g of x, and make sure it's in a grouping symbol so you know that it is the entire g of x, and g of x was this green function right here. The most common mistake is students forget to distribute the minusing into the entire g of x. So what do I actually have? I had this original blue, and now I'm subtracting the 6x, and I'm subtracting a negative 3x squared, which means I'm adding a 3x squared. So now I'm going to go ahead and combine like terms. X squareds can only go with x squareds, so a negative 1 plus 3 gives me a 2x squared. X's can only go with x's. Negative 3 minus 6 is a negative 9, and constants can only go with constants. That's a plus 8. So my f minus g of x rule is this right here. Well, now we're being asked to evaluate it when x was negative 1. So I have my f minus g of x rule, and I am supposed to evaluate all of these x's being the number negative 1. So let's go ahead and evaluate. Exponents come first. So this is 2 times the negative 1 to the power of 2. The entire negative 1 to the power of 2 is positive 1. Now multiplying, this was a 2 plus 9 plus 8. Adding from left to right, I end up getting 19. So my f minus g at negative 1 is a positive 19. So now let's go ahead and look at the domains. I have to look at each individual domain. So first, f of x. This is a quadratic function. It's a downward-facing quadratic function. Quadratic functions, downward-facing, look like this. He's forever to the left and forever to the right, which means this function ends up having all real numbers as its domain. Looking at the domain for g of x, this is also a downward-facing quadratic, which means he will also look similar to this, which is forever to the left and forever to the right, which means his domain is also going to be all real numbers. So now we just need to look at the domain of our f minus g of x rule. What do both f and g have in common? Well, f said everybody. G said everybody. That means f minus g is also going to say, hey, I will use everybody. So his domain is also all real numbers. There are 3 problems left on the page. Please do those 3 problems for independent practice.